Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Computer Wednesday, we're going to talk about Raspberry Pi Pico. So let's dive right into it. Well, first, what we are talking about? We are talking about a microcontroller from Pi Foundation. Now, Pi Foundation has already been known for making actual computers in a single board format, but this time they are doing something different. So it's not just a different unit or modern unit, different unit. No, it's a different product category of microcontrollers. Now, the unique selling point of this puppy is that it was made on ARM system. There are many microcontrollers that use that, but this is in-house, aka they took basically exactly how Samsung takes ARM cores from basically ARM holdings, and then they integrated in their Exynos lineup, or same way basically ARM licenses out their core technology to Snapdragon. Snapdragon integrates that and makes basically Qualcomm integrates them into Snapdragon. That's the same thing is happening here. So this silicon is custom to Raspberry Pi. They built it from scratch one. There was a primary reason for that is like they looked into all the alternatives. It was nothing was matching the way they wanted it to. So basically, if they wanted low power consumption, they were like, dude, there is no feature in this. If they wanted a lot of RAM into that, basically from microcontrollers point of view, there's like, dude, it's gonna cost an arm and a leg. So reality was they wanted to create a Arduino alternative which has to be really good in multiple ways. Like it's not a precision tool, it's not like the best and latest and greatest, but what it is, it's like damn awesome. Now, selling point for normal consumer is that it's super affordable. For example, you can get it on hand for $4. Like that's cheap. Like that's really freaking cheap. Like even in India, people are actually able to order this puppy for less than 500 rupees. So to give you a context of that, that is cheaper than this Arduino Micro that I paid. And like once I created documentation for this on Amazon, it's like the pin diagram was wrong. So I created a right pin diagram, and it's like randomly the price went to 900 rupees. So you can understand that like it is 8-bit system, and I can get a 32-bit system for much cheaper price than this. So there is no competition here. It is truly mind-bogglingly affordable. Now that's the whole selling point of RP2040. Now what's unique about it? This is a dual core system. There are ARM based microcontrollers, but most of them are single core. Like again, low budget ones. High budget one, you can go YOLO on that, but low budget one, that's a very unique point. And these have Cortex M0. So if you go to talk to ARM and you're like, hey, I want to replicate this, like that's what they are utilizing. Now clockwise, it can run up to 133 megahertz, which is really good. Be mindful, most microcontrollers are like in double digits. This puppy touches triple digits. That's really good. And be mindful, this can be scaled down also. So let's say you want to make something that that is not very intensive, but you want the power consumption to go way down. It's like, bro, power consumption down. This puppy can do that. Now this has 264 kilobits of RAM. Now that may sound very low if you're coming from mobiles and all that jazz, but for microcontroller, that's a lot. Be mindful, many microcontrollers have less memory than this, and it has 2 megabytes of flash. Now you may be like, okay, if microcontroller runs on 256 kilobits of space, why the heck you need 2 megabytes? The reality is, like, for example, if I want to make a watch with this puppy, can I make it? Yes. If I want to replace a digital watch, like I can make this, but problem is if I want to use a, let's say, e-paper display, e-ink display, the problem is the library of e-ink will almost consume the whole thing, and after that I will not have the luxury of installing extra fonts and all that jazz. So that's an issue that many people have faced with low cost microcontrollers. Like, dude, that's why Raspberry Pi Foundation built their service. Like they learned this the hard way. It's like if you want to do something, it's like no, you have to optimize every single last code that is going into the system. Now that's acceptable for, let's say, LG, Samsung, Panasonic. If a big company is like building a product, they can afford to do that. You and I can't afford it, so we have to have that buffer. That's why that 2 megabytes of flash is really good. Then we come to how many GPIO pins, basically how many these things we have. They have 26, which is good, which is really good. Like it's not the best, but it's really good for many scenarios. That's good enough. And it also has accurate clock, RTC. Basically, if you can provide it with battery, you can have a clock function, which if you see any basically Arduino clock, you will always see people are adding a module, independent module with a coin cell and all that jazz to make sure they have a RTC functionality. So that's really good. This also has temperature sensor, which is also useful if you figure out how to utilize it. And it also has 12-bit ADC. Now that's really good, because be mindful, at this point in time, most ADC you are gonna get on low budget system is 8-bit. So that's really good. Now let's understand the design aspect of it, and this is where they like, you know, knocked it out of park. This is like where they studied Arduino, they studied each of their competitor, and they're like, what if I give you best of both worlds? For example, I always suggest people start with if they want to start with Arduino. I won't do that anymore, but if they wanted to start with Arduino, I will say like Arduino Micro. Why? A, it has the ability to directly communicate with USB. Awesome. B, it has the ability to directly be plonked on top of a basically breadboard. Basically, you have a breadboard, you plonk this puppy in, and done. Now you design your whole circuit, basically plonk multiple breadboards together, so you have a bigger breadboard, lay out your whole circuit, and once you are done, you can be like, okay, you can detach this without any soldering and all that jazz, and you can make your own circuit. I know this was my first project, don't judge me too hard, but then you can directly plonk this here. Sorry about that. So you can plonk it here, and now you have a, you know, human interface device. I basically built this as a, like, you know, controller for my computer. It does work. Everything on this does work. It's a functioning system. It's just like I never polished it, and it did not work with Lightroom the way I wanted it to, so I abandoned this. But that's the whole thing. Like, you can build a complete system utilizing that pin array, and it has that. So the pin spacing is compatible with everything. On top of that, it has edge castellation. Now that's unique thing. Now what this simply means is basically they have holes, and after that they have semicircle, it's like a 180-degree, and it is properly copper clad, so you can solder to that. Now you may be like, why the heck you want to do that? Because the PCB was designed from day one to be utilized as in a PCB mount scenario. They designed it in such a way that backside is completely clean. What does that mean? That simply means you look at the backside, it's flat. You can plonk it down on top of any existing PCB. So let's say, because nowadays PCB manufacturing functionalities are so cheap, you can like spend less than $10 and get a professionally made PCB. Let's say you built a PCB. It's like, let's say keyboard, for example. That's a really popular nowadays. You built a mechanical keyboard and you wanted to plonk this puppy down. You don't need to make a go through all this structure of having that pin and hole system. You can directly plonk this down and solder it. Done. That is done professionally. So be mindful. Heck, I'm pretty sure if you open many equipments in your household, you will find, hey, the GPS module is plonked on exactly like that, using that edge castellation. So that's really good. So they have best of both worlds, where you can directly PCB mount it if you need to, or you can utilize for basically pin based in breadboard. Like breadboard would be like starter, and then once you are like, okay, I'm done, I want to make final product, you can directly solder this puppy to the PCB. That's really good. So that's why the backside is completely clean. So design wise, it's a really good implementation of a basic function. It's like, how do you give pins to your user? Really well done. Awesome. However, there are two things that are a bit annoying. One of them is truly annoying, is like, why the heck your silk screen is on the back? Now silk screen on Arduinos are generally always on top, barring like I think every nano. Most of the time silk screens are always on top. Even in Tinsy, which has much higher pin density, they have everything on top, and it's a necessary, because without it you will get lost. Now again, if you're an engineer, like, dude, I can close my eye, I can directly count it, and I will know this pin is like, you know, a run pin, this is GP pin 22, this is GP pin 7. I get it, but this is not targeted for engineers. This is targeted for normal, you know, blokes. And you spent money on that silk screen. Why the heck you put it on top? Basically bottom. And specifically, if you did the PCB mounting, you will never have the luxury of seeing that. So that's really odd. And not to mention, there is this empty space on top. It's like, there is empty space. Why the heck you did this? This is truly bizarre. It's not odd, it's just bizarre. Why the heck you did that? It's like, you have space, you have more than enough space, man. So that's one odd thing, especially like as a, like, if they wanted to market this as a, like, you know, children's friendly system. It's a really odd, like, come on man, market, come on. And you spend the money, it's just like spent in the wrong direction. So that's minor annoyance, and I'm pretty sure they should be able to fix it. If they are not too stubborn, by Gen 2 or Gen 3 they should have easily fixed it. Another thing which I understand it, but it's kind of painful, is that for cost cutting they are using USB-C, not basically micro B, using not USB-C. Now you may be like, wouldn't that have increased cost a lot? Not really, because SparkFun, because this microcontroller is for sale. So if you want to make your own product, you can do that if you can order them in large enough quantity, and SparkFun did that. So they have their own multiple PCBs designer already on. This is almost the same form factor as Arduino Pro Micro, and many people utilize that to make basically human interface device. Like same way I built this, many people have built much more professional system where they have PCBs, custom mechanical buttons, and like 3D printed enclosure. They go all out. So in those sort of scenario, having a USB-C would be really nice, and they have provided that. So that's doable. It's just like little bit more, like instead of going to a low cost of $4, they are like $5, and they have given USB-C. I'm pretty sure more people would be able to actually utilize this as is, because if you have that, like, actual USB-C, that makes it like a much closer to final product. Because nowadays, let's say you want to launch a Kickstarter where you sell, let's say, 100 or 200 of keyboard, that would be a bit of a pain point. So design wise, silk screen is really lame. It's like, does not make sense why the heck it's like that. And USB-C, I can understand that. It's like they would have easily gone to from $4 to $5 if they have done that. So okay, so design is really good, but it's just like those are 2 points, pain points. Now we come to the absolute aspect of it. Is it well supported? Now this is the one thing, because it's a must for success. If you do not have support architecture laid down before your product reaches to market, your product is gonna flop. And there are many Raspberry Pi clones. Most of them have disappeared. That is the primary reason for it. They do not have community. They do not have support. Basically, you don't want people to spend time, what the heck I'm supposed to do with this? Like, every question they could ask, it should have been already answered. And I have really bad experience with this now. I do not know who to blame for this. It's like this Arduino Micro, I bought it, like apparently this is original, and I bought it, everything is working, but the pin numbering was wrong. Like in the diagram that came with this puppy was like pin number 24 to no, pin number 18 to 20, but it was not working. I thought like it was defective, but randomly I tried to use that pin for large number, right? Directly it started to work, and I'm like, then I narrowed down, like pin number 19, no, 20, no, 23, okay, now it's starting to work. It's like the pin numbering was wrong. So that's a big issue, and it has happened with many other microcontrollers. Like, people have to spend like, okay, what is that exactly pin number? Now that's a very frustrating thing. Now Raspberry Pi, because they have already built enough experience with Pi foundations, they are like, no, we're gonna lay it down properly. So you type pin diagram for people, like, you're gonna get one diagram and it's gonna be absolutely perfect, absolutely reliable. So that's a really good thing. So they are laying down good documentation from day one, and they are supporting MicroPython and C++. Now MicroPython is really good for starting out. Like if you want to start out, and for more than enough things that you can do with this, is like more than good enough. But if you're like, I really want to go deep, go with C and C++. So that's a really good thing. That's like, if you want to go deep, we can go deep, and if you want to, like, just figure things out, enjoy MicroPython. That's a really good documentation right there. And in terms of documentation, they actually went with the trouble of actually making a full book. That's really important. Like, most people don't understand the value of making a book, but think of it this way. Let's say you are a person who are a tinkerer, who know everything about like making a microcontroller work, making a Raspberry Pi work, but do you know exactly how this microcontroller works? No. So what would that mean? That means simply you will not be able to utilize this puppy to its full potential, because you will have gaps in your knowledge. And books are really good to make sure that does not happen, because they will be organized, classified, documented, indexed. So if you actually go through book from point A to point B, like as in like full book, you'll be like, oh no, now I know every context of it. Now how do you utilize it? That's up to you, but you will not have a gap in your knowledge. So that's really good. Like that, they laid down the foundation, and this book was the book will be available after 1 month. No, it's ready to go. Ready to go, take it and go. So that's really good. And third-party boards are also supported. So for my example, for many people, they don't need that high of pin count, but they need USB-C. SparkFun is like, I got your back. And maybe even Arduino is working with them, so they might also have a board coming out soon. So that's really good for like just starting out. They're really nailing the support aspect. Now let's compare it to Arduino. Now think of it this way, Arduino is starting to feel very outdated, because most of the time when I say Arduino, you are thinking about 8-bit microcontrollers. While they do have 32-bit system, internet on thick systems, those are idiotically expensive, and that is starting to show up at this point in time. They are no longer competitive in price. Like for example, this puppy costs more than Pi Foundation, and this is 8-bit system. So that's the main thing. That's finally starting to show up. And for example, there are a lot of good alternatives which cost less and has more performance. For example, Ep132. Now this puppy has a wireless and all that jazz, and it also has that module system they utilize. That's why I'm saying like Raspberry Pi learned from the best. They're like, okay, you have the cascaded system, so I can design my thing and then make a PCB, then desolder this and plonk it on. And Raspberry Pi Foundation is like, what if I make that into one step? You have your pin, and once you're done with it, directly solder it on. So that's awesome. So they learned from this. This is a really good system if you want low power Bluetooth connection, low power Wi-Fi. Awesome. Then you have Teensy if you want a lot of brute force and a lot of pins. This puppy got you covered. Then you are talking about STM Blue Pill, also called STM32. All these things are cheaper than Arduino. So that's the whole thing. It's like Arduino is starting to fall back in their price competitiveness. Like, yeah, it's powerful. Yes, they made what we call microcontroller accessible to common public. That's absolutely true. But their price wise, they're like every day they are slipping behind. Like I did not even knew they had like multiple high end options there. But the moment I looked at the price, yep, that's why you don't see them. That's why you see Teensy and ESP32. They have competitor for all this. You just don't dare to compare the price. So that's the reality. And given the fact that Raspberry Pi is laying down the foundation and they're dealing with other manufacturers also, it's like, hey, SparkFun is like, hey, I have an idea. It will sell well. They're like, okay, go. Take it and go. Like if it works out, awesome. Then I can be damn sure like by the Gen 2, they will have USB-C. So a lot of good potential here. Like an Arduino really have to improve their cost competitiveness. Otherwise, they will disappear. So this was my presentation on Raspberry Pi Pico. I hope you liked it, learn from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike. Press it twice to show me extra disappointment. Please leave a comment because I try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.